All right, let's dive into one of nature's most incredible, most baffling mysteries. We're talking about the epic journey of migratory birds. I mean, how on earth do they do it? Seriously, think about it. How do these tiny creatures navigate thousands of miles over oceans across entire continents with pinpoint accuracy every single year? You know, they don't have GPS, they don't have maps, they're not following their parents on their first trip. It's in an innate biological system that scientists are only just starting to wrap their heads around. And let me tell you, the answer is way stranger and way cooler than you could possibly imagine. Okay, so first, let's really get a handle on the sheer scale of this journey. This isn't just a trip across town. No way. This is one of nature's greatest epics playing out right over our heads. I mean, just picture it. Some of these birds travel tens of thousands of miles every single year. And they don't just land in the right country, they often come back to the exact same spot. The same tree in a backyard, the same nesting ground. But here's the real kicker, the part that blows my mind. A young bird, on its very first trip, can make this journey perfectly with no guide. That's not something you learn. That has to be some kind of built-in sixth sense, right? So for decades, scientists were on the hunt. They were looking for the biological hardware behind this incredible sense. They checked the beak, they looked in the inner ear, but the trail eventually led them somewhere, well, somewhere they never expected. Get this. It turns out migratory birds have vision-based magnetoreception. They can literally see the Earth's magnetic field. Yeah, you heard me right. They don't just feel it like a little pull from a compass, they see it. It's a layer of information on top of their normal vision that we are completely blind to. Now, that's a revolutionary idea, right? And it took some seriously clever experiments to back it up. The evidence started piling up. First, back in 2005, researchers found this specific part of the brain, they called it cluster N, that lit up at night in migrating birds. And it was a part of the brain that processes visual information. Then, a few years later, more experiments pointed away from the beak and inner ear and toward the eyes. But the real game changer was this experiment in 2010. They put tiny frosted goggles on European robins. And what happened? They got totally lost. And here's the crazy part. They only got lost if their right eye was covered. The compass wasn't just in the eyes, it was specifically in the right eye. Okay, so how in the world can an eye see a magnetic field? Well, the answer isn't in your standard biology textbook. For this, we have to take a leap. We have to leave the world we're all familiar with and dive headfirst into the weird, wonderful, and totally counterintuitive world of quantum physics. And that brings us to the hero of our story, a molecule called cryptochrome. It's a protein that's sensitive to blue light. And you know what? You have it in your eyes too. For us, it helps manage our internal clocks, our circadian rhythms. But in birds, this little molecule seems to have a secret, incredible second job. It's the key. It's what unlocks their quantum sense. Okay, buckle up, because this is where it gets really wild. The leading theory is called the radical pair mechanism. And here's the gist of it. When a photon of blue light from the sun hits one of these cryptomicron molecules in the bird's eye, bam, it knocks an electron from one part of the molecule to another. Now you have what's called a radical pair. Two electrons that are quantumly entangled. Their fates are linked. Think of them like two tiny spinning compass needles that are magically connected. And here's the magic trick. The Earth's magnetic field, as weak as it is just strong enough to mess with how long these electrons stay linked. This change in their spin state, it alters the chemistry of the molecule. And that chemical change creates a signal that the bird's brain interprets as a visual pattern. It's like a filter or an overlay of light and shadow on top of everything else it sees. So to be clear, the bird probably isn't seeing giant glowing arrows in the sky pointing north. It's probably much more subtle. As one research group put it, the visual field of a bird is modified through the magnetic filter function. It's an extra pattern, maybe of light and dark patches, that shifts as the bird turns its head. And that pattern gives it a constant, totally reliable sense of direction. Now, a theory this out there needs some seriously solid evidence, right? I mean, how on earth do you even begin to test something like this? How do you prove that a fragile quantum state that exists for a fraction of a second inside a bird's eye is what's guiding its entire journey? Well, here's how they did it. If this compass really depends on a delicate quantum state, then you should be able to break it, right? You should be able to disrupt it. And that's exactly what a team of researchers did. They put birds inside a weak radio frequency field.
Now, this field was way too weak to mess with a regular magnetic compass, but it was tuned to the perfect frequency to jam the quantum spin of those entangled electrons. And the result? The birds got lost. They were totally disoriented. This was pretty much the smoking gun they were looking for. And those experiments allowed them to calculate a really critical number. It's called the spin coherence lifetime. Basically, it's how long that fragile quantum entanglement has to last for the compass to work. And the answer is just 2 to 10 microseconds. That's millions of a second. It's an unbelievably fleeting, fragile state, but it's just long enough for the bird to get a heading and know which way to go.
But, like any good scientific mystery, there's a twist. We have this amazing theory, we have some really strong evidence to back it up, but the case isn't quite closed yet. Science is always a work in progress, and there are still some really big questions hanging in the air.
See, for a long time, there was another big idea on the table. It's called the magnetite theory. The idea was that birds have tiny particles of iron ore, magnetite, in their beaks that act like tiny little compass needles. And you know what? They might. That could be a whole separate sense, maybe one that gives them a sense of location, like a map. But the radical pair theory, the one in the eye, is the one that best explains things like why the compass is dependent on light. That's a huge piece of the puzzle. But here's the biggest hurdle for the quantum compass idea. The thing scientists are wrestling with right now, it's called the sensitivity problem. Basically, how can the Earth's magnetic field, which is super, super weak, have any real effect on a quantum state that collapses in a few microseconds? The theory is beautiful, but making the math work is really tough. It kind of suggests we're still missing a piece of the puzzle, maybe some kind of biological trick that amplifies the signal. But here's why all of this is so exciting. This whole story about the bird's quantum compass, it's about way more than just birds. It's become the poster child for a whole new revolutionary field of science, one that is fundamentally changing how we think about life itself. It turns out, when you start looking, you see these quantum tricks everywhere in biology. Photosynthesis, it uses quantum effects to move energy around with almost perfect efficiency. The way enzymes work, they use something called quantum tunneling to speed up chemical reactions. There are even wild, though debated, theories that our sense of smell, and maybe even the stability of our DNA, relies on these bizarre quantum rules. The name for this new field is quantum biology, and its central idea is, well, it's absolutely mind-blowing. It suggests that evolution isn't just about chemistry and classical physics. It's a quantum engineer. It's figured out how to harness the absolute strangest parts of physics over millions of years to solve problems and give life an edge. It's incredible. And that brings us right back around to us, to a final fascinating question. Because guess what? Humans have a version of that same light-sensitive cryptochrome molecule, it's called CRY2, in our own retinas. And in lab experiments, it's been shown to be sensitive to magnetic fields too. So, okay, we're probably not about to navigate across the ocean with it, but it makes you wonder, doesn't it? What subtle information, what layer of reality might we be sensing without even realizing it? What kind of quantum sense is lying dormant right there in our own eyes?